part. So I, for one, am very excited. We have a vaccine coming, so I guess that's going to be the end of all problems. We're headed back to a completely normal reality. COVID will be a thing of the past, and we'll just go back to life as usual. That's great.
Of course. Hey, podcast done.
We're done.
All right. Good job. No.
So, I was educated myself on the, as a physician, you don't have a bead on emergent vaccine technologies. This is, neither of ours fortes, right? We're not experts at different vaccine technologies. And so when the news of the Pfizer and Moderna vaccines came out, I was somewhat surprised by the efficacy. It's like, oh, this is 95% efficacious against preventing you from getting COVID-19. That's a bit unusual because our models are usually, the closest models we have for this is like the flu, right? And not to get into the flu conversation.
No, sure.
But the flu is not very effective, at preventing or mitigating, the symptoms or anything. And this apparently, the Moderna and the Pfizer vaccines, the AstraZeneca vaccines, they're actually not the AstraZeneca, just the Moderna and Pfizer vaccines.
Yep.
The new mRNA vaccines are supposedly extremely efficacious based on preliminary data, which, as I understand, and if you understand differently, let me know, is based off of just 30,000 people.
Yeah, 30,000 people, and more importantly, 95 cases. Right. So yeah, 30,000 people, but out of that 30,000, there were only 90 cases of COVID. Right. So that's also an important aspect. Right. It's also important to frame that the study setup, the pre-study definitions indicated, before any of these studies were set up, indicated that you would need at least 147 to 167 cases before you could rule out chance. So we're actually not there yet in terms of what we could be seeing now actually statistically could be attributable to chance. They stay at statistically significant, but actually that's a fudge because you can actually reach statistical significance in an underpowered study. And that's been a problem in the drug industry broadly a lot, right? Is they'll stop a study early or they'll stop recruiting or they'll whatever because they've reached statistical significance, fudging on the idea that their study is underpowered.
So before we get into the weeds on this particular vaccine sort of platforms, and there's these two platforms, let's just quickly go over like the different types of vaccines, because one of the, I think, more important things to emphasize is that the word vaccine seems to be just this one thing, right? But it's almost like saying cancer therapy.
Yeah,
right?
yeah.
I mean, it's not, there's a huge variety of different kinds of technologies out there. And it's important to understand that they have different potential side effects and, the pros and cons, even manufacturing techniques, right? And so most people understand that a vaccine is some sort of a thing that's related to a virus or bacteria that you introduce into the body that produces an immune response that then causes a protective effect.
Sure.
One of the simplest ways of understanding is that there's such a thing as a live attenuated vaccine, which means that the actual organism is alive but weakened in some way, so that when it is introduced into the body, it's the actual virus or bacteria, but it's a wimpy, sort of beaten up, someone took it behind the alley and beat it up, and the immune response is still triggered, but it doesn't actually cause pathology. And the good example of this one is the oral polio vaccine, is a live attenuated vaccine. Yep. So that's one category.
It's funny that you find that one the easiest. I actually find the inactivated viral vaccine, a little easier to understand. You take the actual virus, and then you just basically, the Salk vaccine, the injectable polio vaccine, is an inactive virus where it's just basically the actual virus dipped in formaldehyde. Yeah. It no longer works or does what it's supposed to, but it is structurally the virus. Right. So whatever. Those are a couple of differences. The other thing I would say is that I think I have a little bit perhaps of a different perspective in that, I did med peds, right? And on the peds side, of course, we have more contact with, on the adult side, it's basically flu. Okay, you have the pneumonia vaccine or Shingrix, right? But on the pediatric side, you have more exposure to the history of all these other vaccines. And so, without getting too far in the weeds, but I remember like rotavirus coming on, going off, like, and going off and then coming back on, and like all these other questions that have come up. The introduction of the chickenpox vaccine and how much research went into that, how long it took to get, and what the motivations were. I guess that's the other thing. Like, and again, without getting too far into the weeds here, but things that are not commonly understood, I think, so live attenuated vaccine is MMR, right? Well, measles, mumps, measles. The measles vaccine is a live attenuated vaccine, and it's actually 95% effective in the first dose, right? So actually, you only need one dose of measles if you're in that 95%, right? But we developed a pragmatic strategy of giving everybody 2 doses, right? Because the second dose catches that remaining 5%, right? So it's kind of an interesting thing, is an alternate strategy would have been give measles vaccine, wait a certain period of time, check for antibodies or titers, and then only give the second dose for the people or the kids who don't. But it then has a blood draw, it then has other factors and becomes less pragmatic. And so I think there's a number of vaccination issues that are pragmatism based, and we'll come up against that again as well.
Yeah.
So anyway, so live vaccine,
live vaccine, attenuated vaccine, and then you have just antigen particles, right? So you just get some protein.
Protein.
Yeah. So I think the hepatitis vaccine is an antigen-based one.
So is HPV.
HPV is one as well. What is another type I'm missing? I think there's a...
No, then there's the new ones.
Okay, so let's come up to these 2 new platforms. So one of them is
before we do that, actually, I think, again, maybe just for listener benefit, right? I think it's important to just frame the concept here, right? So you mentioned vaccine is something given to the body in some, either orally or injected or whatever, that induces an immune response, right? So there's some background there that's also important, is that these viruses are either DNA or RNA, fundamentally with an enclosure of some kind, right? Some sort of packet along with DNA, RNA inside. It attacks, gets into the cell, and starts replicating new virions, right? Your immune system...
That's what a virus is, right?
That's what a virus is, right? Your cell maybe breaks down in some way or takes some of those particles, presents it, right? And your immune system starts to try to recognize pieces of it, right? Once a recognition happens, then you develop antibodies and so on and so forth. The reason I say that is that, the coronavirus is an mRNA vaccine or mRNA virus, right? So it is mRNA in a capsule that codes certain things, and we actually rapidly developed the sequence. We understood what exactly the RNA was.
I think it was 9 days.
Yeah, it was very, very rapid, right? And so the reason I'm framing all that is that understanding that the path from genetic material to functioning virion, the path from genetic material to protein to antibody, right? Because your DNA codes for RNA, RNA is taken to the ribosome makes the RNA into protein, and that sequential series, what we're looking at with these novel vaccine platforms is attacking that at different points. So the protein particle is just saying, hey, we're going to just give the protein that actually causes the immune response. That's that end product. Right. And now, taking a step back from there, the Moderna and the Pfizer, we're giving the mRNA, and just like the virus causes replication of protein from mRNA, actually we're going to do the same thing that the virus is doing, and it is in fact a part of the viral RNA. So we're actually giving you a part of coronavirus, and that's going to encode the protein, and then you're going to have an immune response to that.
You're right. Yeah. Right? So,
and there are vaccines out there that are actually DNA, and the DNA is going to code RNA. RNA is going to code protein. Right. So.
Yeah, I'm not sure. Yeah, it's necessary to parse it out that much, but so the new platforms, the mRNA platform, is where mRNA is introduced. This is not necessarily the actual entire viral mRNA sequence.
Not all of it, actually, just for the spike protein.
It's just a certain amount that codes for a protein. In case of the coronavirus, it's the S protein, what's so-called spike protein.
Correct.
The protein that allows the virus to attach to the mucosal cells in the body, and it allows it to enter the cell. That spike protein sequence is introduced into the body. And so once it gets into a cell of the body, that particular protein and only that protein and nothing else is produced. And so if it's only that protein that's produced of the virus, there's no other part of the virus that is in the system except for that spike protein. And so, the virus is not replicating or self-replicating. All that is happening is that you have introduced that antigen, which is the spike protein against which we're producing antibodies, in this unusual way. I mean, it's very unusual because one of the thoughts is, well, why didn't you just get a whole bunch of these spike proteins, in the lab and just inject it into your body? Would that not have worked somehow?
That's true. No, the Sanofi vaccine. The Sanofi vaccine is that, actually. So Sanofi GSK is actually formulating a vaccine that is exactly that. And the issue there is in order to develop the same immune response, you need what's called adjuvants. So you need immune stimulators in addition to the spike protein. And HPV has this, hepatitis B also has this, is you have to find the right combination. Actually, SHINGRX also, if I remember right, is also protein-based. And so you got to find the right adjuvants to add to the mix to get the immune response to just the protein. But Sanofi's absolutely, actually, Sanofi and Novavax, I think that's right.
Novavax or the antigen-based, just the actual antigen.
They're looking at antigen solutions. Yeah.
So the novel concept of this is that the antigen that causes the antibody response, the protein that causes the antibody response, is that it itself is not introduced in the body. The genetic code to make it is introduced by the body,
Correct.
And then the body itself makes that antigen, and then the immune system responds to that. And it's a bit complicated. I mean, if there was a diagram, I think it would be a little bit easier to explain.
Yeah, it's one of those things that's easier to draw.
You just can't make it simpler
Yeah.
than what we just said, right? That's just how that works.
Well, I mean, and that's why I kind of maybe went through too much, but like that idea that mRNA makes your body make proteins. That's how your whole body works. Yeah. Any protein in your body is made that way, from your own DNA to RNA to protein. Yeah. And then in this case of the virus's RNA is made into protein. And now in the case of the vaccine...
another way to maybe explain it is that all that DNA does in the body is that it is basically software encode for proteins. And it's a protein that does all the stuff all the bodily stuff of the cellular stuff is done by proteins. They're the workhorse. Proteins are conjugated with other things as well, so it's not just purely proteins, but all life begins with some kind of protein that is encoded by the DNA. The way that genetic code gets from the nucleus, which is where, of course, the DNA is, into the cytoplasm, which is outside of the nucleus, is through this mRNA, M standing for messenger RNA.
Correct.
So the messenger RNA basically just takes the code. Hey, here's the code. Here's what we're transcribing today.
Right.
And then that protein is made.
Sure.
And so in this very unusual, novel way of this mRNA vaccine, we're just sort of hijacking that middle step where we're saying, here's the mRNA you're supposed to, here's the new thing we're making today. And that new thing happens to be the spike protein. So I hope we've explained that as simple as possible.
It's one of those things, again, pictures worth 1,000 words, and you just slip something in there. But the reason I keep doing that is that in this pathway, right, what the new platform has done is taken us back a step. Rather than trying to introduce the protein, we're going to introduce the RNA that codes for the protein and force your body, your cells, to make that viral protein, which is just what the virus does. Right. But it's not the whole virus.
Yeah, it's just that part. So another way of saying this, to make it as simple as possible, one sentence simplicity, is that this mRNA vaccine is basically giving instructions to the body to make spike proteins.
Yes, that's a great.
It is giving the genetic code to make the spike proteins and nothing but the spike proteins, so that the immune system can have an immune response against the spike protein, which then effectively is also an immune response against the coronavirus.
And that's that last step there is an interesting point, right? And that actually, I think, is, for me, the biggest positive of these trials, is that, I think there are a lot of remaining questions. But if these trials can show efficacy, then we know from these trials and nothing else, we know from these trials that the spike protein is an appropriate target.
Right, of course.
Right?
Yeah.
So we have all these questions about safety, which I'm sure we're going to get into, right? But in terms of efficacy, that was actually not obvious. That, hey, because in fact there are other vaccines being developed against, for instance, the encapsulation, right? The capsule, right? So it was not a slam dunk that the spike protein antibody
would have been the best
would
target.
be protective, right?
Yeah. So I guess to some extent there was guesswork. That's why they had, I'm sure AstraZeneca and these others probably have parallel vaccine projects going on as well, and this is the one that ended up showing the most promise. I will say that I think a lot of the pharmaceutical companies had an instinct, quote unquote, that the spike protein was a legitimate target, because that was what was identified as the crucial protein that binded.
Well, that also comes out of SARS and MERS, right?
Yeah,
I mean, we had a history
and
of
coronavirus in general.
Coronavirus in general,
previous
right?
coronaviruses. We've had some experience with coronavirus.
Correct. It wasn't a de novo guess.
Yeah.
Right?
They didn't just throw a
just
dart at the thing. They're like, well, if we target this, we target
spike protein.
So so I think it's I think that's really a settled question. I mean, and I think these vaccine trials will bear that out. That if it does decrease the efficacy dramatically, as this is
it certainly seems that way.
It seems that this is probably the right target.
The right target, and that's important, right? Because out of all the things we could target, it's important to have some idea that yes, if we keep refining. And however you do it, protein, RNA, DNA, whatever you do, right? If you come up to the idea that, yes, the spike protein is the target, that actually simplifies the field dramatically, right? This simplifies the question dramatically. So that's an important aspect that these
So all vaccines will say we need to target the spike protein. And
I mean,
at
the very least,
fashion, we need to do that. All right, so I think we explained the sort of mechanism of how it works. One over the spike protein is a legitimate target.
Sure.
Now, mRNA vaccines, well, this will be the first mRNA vaccine deployed, as far as I understand. I don't know of another mRNA vaccine that has ever been developed. In humans, right?
Yeah, correct.
Why is that a problem?
So, well, a couple of reasons, actually. And actually, before we get into that, I want to mention a couple others. So the AstraZeneca, for instance, unlike Moderna and Pfizer, who are using a liposomal transmitter, right? Meaning that they've taken the mRNA and just encased it in a droplet of fat, basically, right?
And that's how they'll introduce it into the body.
And the fat then will go into the body, and the fat, and then that'll how to get in. AstraZeneca is actually using adenovirus 26, I think, right? So it's actually, they're using a virus that they have inactivated, and actually it's a novel inactivation method, by the way. So they're not just dipping in formaldehyde, but they're using a virus and then including this spike protein mRNA in that virus. So that virus then comes in, infects you, quote unquote, and then distributes the mRNA, right? But the virus itself being inactivated or partially damaged, actually, they only encode part of the RNA of that virus. It can't replicate, so it just kind of gives this mRNA, right? And the last point I'll make is that how do these protein, the protein-based vaccines we talked about, how are those made, right? Is actually you take the same mRNA, right, and you put it in a yeast cell, and you just tell the yeast cell to make it for you.
Sure, yeah.
So it's actually all the same thing on some level. The virus itself codes for this spike protein, but it also codes for the rest of the virus, so that's a problem. Then we say, okay, well, what if the mRNA, we just give that to the cell, and we make our cells make the spell protein, or we have a different virus, put it in our cells, and still our own cells are making it, or then we give it to a yeast cell, say, hey, yeast cell, you make the spike protein, we'll harvest that spike protein and just inject that, right? So it all kind of comes out to the same thing, but there's some steps there that are different between the vaccines. And why the mRNA vaccine in particular might be a problem is that there is reverse transcription from RNA into DNA and reintegration into our genome. That's one possibility, right?
So have you read that somewhere to be a certainty? Because I couldn't find
as far as
this.
possibility.
So let's just describe what reverse transcription means. So again, the arrow of the process is that the DNA codes for proteins. So if you need, say, an antibody, let's say an antibody is a protein that you want to code for, the software for that is in the DNA. That software is moved to the outside of the nucleus, which contains the genetic code, by the messenger RNA. Messenger RNA then turns it into protein using ribosomes. We won't get into
Correct.
that, but so that is how it works. DNA turns into mRNA. mRNA turns into proteins. Now you're saying that what can sometimes happen is that the mRNA can work backwards and reverse transcribe. So we call the transcription of DNA into mRNA, we call that process transcription, because
Correct.
basically the mRNA is just copying what's in the DNA and moving
Correct.
it out of the nucleus. That process is called transcription. Reverse transcription is when that mRNA goes back and encodes itself into the DNA. And that's what you're saying you have read that happens?
So first of all, that's how HIV works. Right. So HIV actually comes with reverse transcriptase. And so importantly, actually, in now, the trials that are happening are including a certain number of HIV patients. So that's important because their cells will have circulating reverse transcriptase. We know that. Now, separately, there's an interesting question here is, does that happen de novo? Meaning, even without HIV being involved, is there a certain amount of reverse transcription? That's an interesting question because in the body, if you just give mRNA in the cell, right, it actually has a very, very fast degradation rate, like within minutes to hours, right? Yeah, and so we're not talking about days, we're talking minutes to hours. So why is it that we're getting spike proteins being generated for days from mRNA, right? And there is some, I don't know that I've come across a credible confirmation source, but there is some indication that the reason is that it's reverse transcribed into a free-floating, non-integrated piece of DNA. And then that DNA codes mRNA ongoingly
I see.
in order to prolong that effect. And it's still only days. It ultimately degrades because it's sort of free-floating. It's not protected in the nucleus. Right.
So that DNA it's in the cytosol. It's not in the nucleus.
That's my impression, but again, I was also very shaky on that. I could be completely wrong on this. If anybody can find confirmatory information on that, that'd be great.
The only thing, you mentioned HIV is reverse transcriptase as well, but the HIV virus has a whole bunch of machinery to enable that RNA to be reverse transcribed, right? And so if you just had a naked, very sort of limited amount of code, in the mRNA that you're introducing as a vaccine, you would need to have additional machinery in order to take that and then turn it into transcription, because the HIV virus comes with the apparatus, like I want this genetic code in that DNA. Right, and so this naked mRNA vaccine wouldn't have any of that genetic information at all. This adjuvant genetic information. So if you're contending that there is a risk of reverse transcriptase, then actually, yes, I see a potential huge problem, right? For all the reasons we can get into.
Yeah, but I guess actually my bigger point is different than that, right? And this is something I thought a lot about actually before we kind of sat down and how to make this point. The bigger point is that whatever objection I come up with, whatever potential disaster scenario I could spin, number one, it will be far-fetched by nature, by definition, right? Number two, not only will it be far-fetched, it's also almost guaranteed to not be the problem that we should be concerned about. And the reason for that is the most important potential side effect is the one we don't think will happen. And by don't think will happen, meaning we didn't even think about it. Like, it's not on our radar. That's the one that actually is going to be a problem. And we saw that with rotavirus, right? The original Rotashield vaccine came out, and it was nowhere on anybody's radar that this might cause intussusception. That was not even a blip on anybody's
So we should
mind.
probably get into the rotavirus, because this gets to the conversation of, unforeseen side effects of vaccines, right? So the rotavirus was a virus made for children against, what was the name of the virus?
Rotavirus.
It's the rotavirus itself.
Yeah.
And so the rotavirus causes severe diarrhea in kids in third world countries. This is actually quite
everywhere. It's in the U.S. as well. I mean, it causes pre-vaccine, right? Caused hundreds of thousands of cases of It was endemic. Basically, everybody by age 5 had it.
No, I was going to say death. It causes actual death in third world countries where there's poor access to resources.
Sorry, I didn't let you finish.
Drinking water is an issue. It actually causes, a lot of kids to die. So it was an important vaccine to be created.
Yeah. Almost 500,000 a year, actually.
Died.
So,
right? Yeah. And so it was a huge source. I mean, all it is diarrhea. That's all it is. It's severe diarrhea.
And we see that, because it was 40 to 60 in the U.S. Right, compared to 500,000 globally. And the reason is that in the U.S. we have great resources.
Yeah.
And it's just IV fluids.
Exactly.
At the end of the day, you come in, the kid's almost half dead, whatever. You put a central line in, you do whatever,
fine.
and then you whatever you have to do.
Whereas in third world countries, even that little amount of just giving IV fluids is an issue. Although they've used ORS.
Mom's going to carry the child for 20 miles to walk to the nearest city, right?
So the rotavirus was a very important virus that was created, and I think what was the first iteration of
That's right. The rotavirus vaccine was created.
The vaccine was
There are enough conspiracy theories out there. We want to say the virus is great. Right?
It was one of the an important vaccine to be created, and then it ended up causing a relatively rare, quite rare side effect called intussusception, where the small intestine kind of telescopes in itself and just kind of gets stuck.
Correct.
And because it telescopes and gets stuck that way, it's essentially an obstruction of the bowel.
Obstruction, and also can cause ischemia, right? Because it's folding on its own blood supply as well.
Potentially quite devastating, side effect. So what was the rate of intussusception in that?
Somewhere between 1 in 10,000 and 1 in 30,000.
Yeah.
Right, and the original study that led to FDA approval of the first rotavirus vaccine, which was called RotaShield. The original study had 15,000 participants, 10,000 I think in the trial and 5,000 placebo or something like that. So it wasn't an even split.
So this is an excellent example of how a serious side effect like intussusception, which requires a surgeon a lot of the times to resolve. If the frequency of such a serious side effect is as low as 1 in 30,000, let's say, a study that involves 20,000 people is probably not going to capture that, right? And
even if it does, you can't tell from whether it's chance.
It was chance or not, yeah. So you would have to give it to 200, 400,000 people, 1 million people before, there's a higher case of this intussusception thing, and then you work out why it happened. There's a pathophysiology. We won't get into that, why intussusception is occurring.
No, but that's actually important. On some, not the exact pathophysiology, that's not important, but what is important is this idea of what we understand looking back versus what we understand looking forward. And this is kind of the Taleb black swan idea, right? So the 3 elements of a black swan event is that, number 1, it has a huge impact, right? Number 2, it was completely unforeseen. And number 3, interestingly, he includes as a criterion that it is explained after the fact.
Sure.
Right? And the market crashes are like that. It's, we should have known because of the housing bubble. Nobody knew ahead of time. Nobody thought that was going to happen, right? Same with rotavirus, right? We did a study in 15,000 people, looked great, very effective. Nobody thought that was going to happen, right? And after the fact, you can say, oh, yes, now it makes sense because it can cause some lymphoproliferative swelling because, of course, you're triggering the immune system in the gut, and because of that swelling, that can be a source for intussusception, right? But that's an after-the-fact understanding. And that's the key difference, is that after the fact, we can make ourselves feel better by telling ourselves, oh, we understand why that happened, right? But when you're looking forward, no one expected that.
So the point is that you can have side effects that are unforeseen at the onset, side effects that you wouldn't even think of, like this would happen. And then later on you can make a story of, it was obvious why it happened. And then that is the case, that was the case in the rotavirus. And that could be the case, to bring it back to this mRNA vaccine, that could be the case in the mRNA vaccine, right? And this is something that, or any vaccine.
Any vaccine. That's the bigger point.
Well, perhaps more so for the mRNA vaccine because it's a completely new platform. platform, right?
Correct.
So we haven't ever had experience with the mRNA, at least with the live attenuated vaccine or sort of the replication replication deficient adenoviruses, which is the other
Correct.
platform. You have some experience, right? Oh, we used to give this, attenuated virus with, say, the polio vaccine, and so 1 in 2.5 million cases, you will actually get polio. So maybe there's an actual chance you got coronavirus. In this case, we don't have any narratives to go on. We don't have anything like, well, in the past mRNA vaccines, these kind of things happen. We don't have any of that kind of narratives as all to go on. And, I want to make sure that we don't come across as alarmists, right? We're not saying, and this is where we both, I think, even before this discussion, agreed that whatever concerns we start raising, I
don't agree with you on anything.
Whatever concerns we begin to raise are open for gross misinterpretation because there's a lot of nuance there, right? So just to piggyback on this rotavirus example, 1 in 30,000 people got a serious side effect, which led to the discontinuation of the vaccine, right?
Correct.
Now, 1 in 30,000, is that a high number or is that a low number? And to some extent, that is subjective, right? It depends on the side effect, first of all, but it also depends on what is the. So let's, for example, say, actually, this is a good launching off point. We have the mRNA vaccine. We deploy it, right? And 4 months later, we've given it to 10 million people. And we find, just like the rotavirus, there's a 1 in 30,000 chance of you getting X, whatever that is, right? Then the next question is, okay, are you going to discontinue it?
Right.
Is 1 in 30,000 an acceptable risk profile for that X, right? And then the question has to be, what is that X? Does your brain explode, like your eyes pop out of your head 1 in 30,000 times?
Right.
Or do you get diarrhea for a week and maybe you're hospitalized, but you get better, right? And so so 2 points here. The question of whether to discontinue it, if it's 1 in 30,000, whatever, is first of all, we don't even know what the X is. Like it's a new platform. That X could be, and your skin turns green permanently, right? And you glow in the dark forever, right? And that is like 1 in 30,000 people are just going to be glowing in the dark from now on, and that is the legacy of the mRNA vaccine. But the next question is that even if that were to happen, we are in a unprecedented, this is a cliche, right? An unprecedented situation where if you don't get herd immunity through vaccination or whatever, and reopen the economy, we're looking at the collapse of modern economies, right? And so that's the downside. And so this is one of those few times where clinical decision-making has to incorporate social, design as well.
Yeah, but vaccines have this issue. So let's talk about the RotaShield vaccine, right? The reason it was taken off the market is because 1 in 30,000, if deployed to all children in the entire United States, is more than 40 to 60, right? So, 40 to 60 deaths versus insusception. So maybe that's a trade-off, but you can't just do an apple-to-apple comparison. But there's actually an argument to be made that taking it off the market in the US and making it unavailable to the rest of the world until the new vaccine came out was actually a net harm.
Yeah, that's right.
Because the rest of the world has a much higher mortality rate. Yeah. And so maybe they would have accepted a certain amount of intussusception.
That's right, yeah.
Right? And similarly here,
that's a good point.
Getting into this idea of like, well, it's not just uniform. You have to compare it to, well, if not this, then what?
So you said that a bit too quickly. Let's just rephrase that, because that's an excellent point, right? Just to rephrase, I'm going to be your translator for like 2 minutes, okay?
Yeah,
so
please.
So the rotavirus, the rotavirus had a 1 in 30,000 cases causing this intussusception, which could have been fatal, devastating, whatever. But the rate of rotavirus in the United States was still much lower than it was in, say,
the rate of harm because of the IV fluids, like we talked about.
Yeah, exactly right. The rate of harm, because you could get a kid in over here, you could rehydrate them, they wouldn't die. In some African country, however, way more people were going to die of the rotavirus than would have died of intussusception.
Correct.
So discontinuing the first vaccine that caused intussusception was probably a net harm, and that's the point you're making. And that really comes down to that question is, you have the risk of, say, the mRNA vaccine, you have the risk of causing X.
Correct.
But then you also have the risk of, worldwide economic shutdown, which is not a medical problem, but it still is.
It's actually not just that, right? And let's talk about the harms, right? Yeah. Economics is on everybody's mind. I'm not convinced that's the biggest thing. It's big, but that's not the biggest, right? You look at the young athlete data, right? It's looking like 15, maybe 30% of them have some form of myocarditis, right? So what percentage of them are even going to get full recovery? Or are we going to have an entire generation of people that have heart failure at a young age, 40s, 60s, because they had this virus? If we just do nothing, right? We just go for herd immunity, quote unquote, and just let everybody get it, right? And let alone the vasculitis, the brain fog, all these other lingering things, let alone the domestic violence, the child abuse that's going on, trying to currently decline in mental health. And no mistake, chronic disease is a rife environment for mental health issues. We know that in the hospital, right? So now what happens if we have an entire generation of young people, men, because men seem to be disproportionately affected, you have an entire generation of young people where they're getting heart failure at age 40, right? And they have chronic disease from age 40 to 70. Well, there's mental health issues associated with that. There's economic issues associated with that. So it's not just the economy opening per se. There are incredible amounts of harms to not figuring this out.
I mean, death, of course, as well, so there's lots of people dying from this as well.
Sure. And by the way, I like death as a metric because it's easy to measure.
Yeah.
It's not necessarily the most
you're either dead
thing.
or you're not dead.
There's less debate on that subject, right?
There's less fake news.
Yeah, it's very difficult. And in fact, actually, you see a lot of these news articles. Oh, coronavirus is overhyped, or is whatever misattributed. I don't know if you come across. Do you read any conservative media?
I've heard that.
Okay.
If they had coronavirus and got hit by a bus, they counted as coronavirus.
Coronavirus, right? That kind of thing. Death certificate attribution, whatever. And
which, by the way, is horseshit. I mean, I've signed death certificates. I do them all the time. No one has ever stood over my shoulder and told me that I have to sign coronavirus or something.
Correct.
Correct. Just put that one to bed. That has never happened in my career.
No, sure, I get, but. I'll be a little. I mean, at the same time, when I fill out the death certificates, I'm also sometimes confused as to what to put, right? Like, did they die of the coronavirus or with the coronavirus, right?
But the extreme view is that you got hit by a bus and you had coronavirus, therefore it was a coronavirus that killed you.
No, I totally get that. I guess what I'm saying though is that I will admit to understanding the question because there's a subjectivity there. It's a doctor's opinion, like what you died of, right? When you had 10 things going on and you died. Okay, one of those was coronavirus. Maybe that's what I put down. Maybe there's some bias there even, right? The problem is that if you just look at the total number of deaths, matched to this time last year, right? You've got a tremendous spike in the number of dead bodies. So if all of this is just paperwork that's been gone wrong, right? Then the same person who's saying this is all just paperwork nonsense has a huge explanation for where all the dead bodies came from. Right? Mm-hmm. And that's an important reason why death is a great metric and why we use death so much. Not because it's most important. I would actually argue probably myocarditis in young people or maybe not myocarditis, but cardiomyopathy in young people may be an even more important effect. But we don't know if it's going to get better on its own. We don't know what percentage. We don't know how many. We don't know, there's a lot of too many unknowns. We know when people are dead, generally. And so we tend to use that as our marker, rightly or wrongly. We got a little bit off into on a tangent.
Yeah, we did, but that's okay. So what we were getting at is that, say the new platform mRNA vaccines have some kind of serious side effect.
Sure.
Say that rate is 1 in 30,000. There's going to be ongoing discussions going forward about whether or not these vaccines are safe, and so the danger is that there, some person somewhere is going to get, a serious side effect, hypersensitivity, whatever it is, right? Glow in the dark, whatever that is. And then, that's going to be amplified on social media so that the bias will be that, oh, this is causing autism, right? Left and right. Yeah. Adults are now having autism, right? That's going to be the whatever new narrative that is. And I'm not saying, and I know you're not saying that we are saying the vaccine is safe. We're saying that we don't know.
Yeah, but more importantly, actually, and that's a great. I love that statement, right? Is we want to say the vaccine is safe. The problem is, how do you define safe?
Right.
And there's actually important work that's been done. One of my favorite charts is called the Paling Risk Perspective. And it actually is a logarithmic chart of how frequently certain things happen. And what's most interesting about it is that human beings actually have a measurable comfort zone, right? So, the likelihood of like shark attack, right? Very rare, right? The likelihood of dying if you ride a motorcycle exclusively in LA for a year, right? Is like 1 in 1,000, right? And it is right around the 1,000 mark where we start to consider things risky. And we have an intuition on that. Is the things where your mom says, you probably shouldn't do that, skydiving or base jumping, or those are things that will have a injury or death rate around the 1 in 1,000 mark, somewhere between 1 in 1,000 and 1 in 10,000. After 1 in 10,000, we start to become more comfortable. And after about 1 in 100,000, we actually become relatively comfortable, right? And the thing that gets skewed and where social media comes in is our opinion of how often things happen comes from how often we hear about it. And that goes back to a time when we were tribal, where you had to hear directly from somebody. And that's often and that's like the same thing that's happening with coronavirus is many people are like, well, I don't know anybody that has it, right? And so it can't be that bad. That's exactly that same process at work, is that, well, it can't be happening that much because I don't know anybody that has it. And until I do, then I'm not going to assume that the subconscious process that we all have of how risky something is. And then when you do know someone and someone dies of it, all of a sudden your perspective changes.
Yeah.
Right? Because now you know, and all of a sudden your risk estimate gets upgraded based on this subconscious sort of cultural process we all have going on. And social media skews that, right? One of my favorite studies is, what kills more people, homicide or diabetes, right? Most people say diabetes. That's correct, right? What kills more people, diabetes or gastrointestinal cancer? And again, it's diabetes, right, by quite a margin. Which kills more people, homicide or gastrointestinal cancer, right? Most people at that point say homicide, right? Because GI cancer doesn't get that much attention, right? But in fact, it's GI cancer by not an insignificant margin. But because our sense of frequency is skewed by how often homicide is reported and diabetes is reported and how seldom gastric cancer is reported in the media, right? Because of that, we have a false perception of the frequency rate, right? And the same thing happens with coronavirus, same thing happens with vaccines. And in this social media bubbles that are created, you're going to hear more and more about, well, I had got the vaccine and I got this symptom.
Yeah, right.
Right? That could be a 1 in a million symptom, but if it's blown up enough, you're going to hear...
Dr. Oz will drag that kid over to his TV show.
That's right.
Before you know it, there'll be a Facebook group.
Or, and that, even more so, is like that could be chance. That may not be associated with the vaccine. Right. But he got the vaccine, the logical, since you're studying philosophy, the philosophy term is post hoc ergo propter hoc, right? Is after this, therefore because of this, right? So he got it, his left arm stopped working after he got the vaccine. Therefore, it must have been because of the vaccine. Right. Rather than, no, that may not be the case.
The old causation correlation
correct.
as well. Right. So I guess, a good way of framing the problem that's going to have to be answered in the months to come, right, is having a clear understanding that whatever the vaccine, there's no vaccine that has no side effects. This is going to have some kind of side effect because it's a novel mRNA, kind of platform. It may have side effects that are hopefully actually not devastating.
That was the other thing I forgot to mention, is that actually there is another factor that occurred to me, is not only is the mRNA platform novel, right? But actually the spike protein itself is novel. That's not something that we've experimented with before, right? Even through another platform. So let's say a protein platform that we're very familiar with, right? Just hepatitis B, HPV. We've done this before. So we're comfortable with the platform, but the spike protein itself is novel. And it may have side effects that we are not anticipating.
Right.
So any aspect of novelty presents the potential for unforeseen consequences.
Yeah, right. So I mean, it's that point is well made that we are experimenting with a platform that we have no prior experience with before. So there is an unknowable kind of risk out there.
Correct.
Right. So the likelihood, and there's some likelihood that unknowable risk might present itself in the distant future, because we're dealing with, genetic manipulated, we're dealing almost with genetic manipulation. It's not quite genetic manipulation, but it's awfully close, right? It's in the same neighborhood.
That would be higher with the mRNA
Yeah, it would be much higher, because you're not just giving the body an antigen to fight against, you're actually giving the body genetic instructions, like this is what you should be doing now. And so
we can debate, does reverse transcription happen from mRNA? But I can guarantee you there's no reverse transcription from protein to mRNA.
Right, exactly.
That's not a thing.
That's not a thing. Right.
And
so, they're just black box of like what could happen, and we both hope that the answer is nothing.
And by the way, I actually should say, I think nothing.
Yeah, right.
Right? If you're asking my opinion on what do I think is most probable, probably fine. It looks good. Data looks good. No sense of side effects, so on and so forth. But that's a flimsy basis on which to base huge potential problems, right? So in terms of not being alarmist, I think the data looks pretty darn good, right? And theoretically, there's no difference between Pfizer's mRNA or Moderna's mRNA and the virus's mRNA itself, right? This is how all viruses work.
There's a significant difference where the Pfizer mRNA is just a much smaller piece. It's just the spike protein.
But the platform concept, right? That's how all viruses work. It's RNA, transcribed in protein. We fight viruses all the time. This one's particularly damaging, but we're only giving a part of it that we hope will be less damaging, right? But that concept of having mRNA introduced and then our bodies being used to make protein, that's the story of every virus.
Yeah.
Right? And so there isn't something particularly novel there, except that we just made this and are sort of introducing it, right?
Yeah.
So again, do I think there's going to be this reverse transcription into DNA and then all our children are going to come out glowing? Or
I think the only correct answer to that question is I don't know.
Correct.
You can't even say I don't think so. You can only say I don't know. I have no idea what.
We don't know about the super rare effects, right? Because we know up to 30,000 people.
Right. Yeah. So actually, we don't know about the late potential genetic side effects, right? So 10 years later, do the people start glowing in the dark then? Is that when they start glowing in the dark? We have no idea because you're playing now with genetic material. And again, this is not an alarmist thing. This is just to demonstrate, this is just to carry over the point that we are dealing with a technology that we have had no actual experience with before. Yes, it's a vaccine. But it is brand new vaccine technology, right? And so it deserves to be placed in its own category of we are running an experiment here. And we hope, that it doesn't actually cause, some late stage untoward side effects. We're relatively confident that it's not causing any immediate side effects because we've tested it on tens of thousands of people. But at the end of the day, the answer is we really don't know what the side effects are going to be. Now, having said that, I think the best way to think about whether or not you're going to take a vaccine, because I think this is probably, if anyone's listening to this, what they want to get away from this is like, does this mean I should take the vaccine or not? Well, what is the answer? Tell me yes, no, give me direction. So the way that I will think about this, to answer the question for myself is perhaps, if you give 1 billion doses of this vaccine, and then you wait 10 years, right? Just hypothetical, and nothing bad happens, and it's 95% efficacious. There's no long-term side effects after 10 years. There's no, whatever rare side effects are exceedingly rare, and they're all correctable. So that's the best case scenario, right?
Sure.
That is one extreme. And the other extreme is you've tested it on 10 people and they all seem to be doing fine, right? So that's the other extreme.
Sure.
Somewhere along the way, as you go towards that 10 million cases in 10 years or whatever, somewhere along the way, you're going to start to, as long as serious side effects don't develop, somewhere along the way, you're going to have to flip the switch and say, okay, I think it is now safe enough. I think we have enough data to say two things. Number one, that there don't appear to be any serious immediate side effects in the immediate few months. And then to some extent, I'm taking a chance on the long-term ones. I'm hoping that there's no long-term ones, but I need to move on with my life, right? And so I think that's the calculus that I will be making is like, okay, and I don't know what that number for me is. I don't know if I need to see data for 1 million people. I don't know if it's going to be good enough after 500,000 people. Do I need to see, data from 3 million people and I have to wait for 3 months to make sure there's no long-term side effects? But that's the sort of
that kind of gets into this issue, just what we were talking about the rotavirus vaccine, right? Is if you're 80 and overweight and diabetic and living in a nursing home, right? Well, if this coronavirus vaccine has any kind of risk that's less than 1 in 30,000, you're a net positive for taking the vaccine.
Yeah.
Right?
So yeah, but what I was actually answering the question for myself,
for yourself,
as a relatively young person who doesn't live in a nursing home. This would, and hopefully have like 50 years of life ahead of me, that sort of, and also with the odds that I will probably be okay if I do get the coronavirus, so that there's some, calculation made there as well. At some point in time, if a young person is, listening to this and wants to know, like, okay, at what point do I bite the bullet and say there's enough data to prove safety? Mm-hmm. And to some extent, that's subjective. You can't just do a yay or nay, right? You can't just say, well, after 2 million, it's, we're vaccinating everybody, right? Hide your kids, hide your wife, hide your sister. We're coming after everybody with vaccine jabs, right? It's based on everyone's sort of risk tolerance, right? At some point in time, if you're just a very, so I asked a question to a friend of mine recently. I'm like, well, we may not know, for example, we will definitely have more data in a year's time than we do today about this vaccine. Do you want to wait that long? Because do you want to wait that long? Because if the answer is no, the answer is yes, and I want 1 million, people to be vaccinated. I want 1 year's worth of data. Then what you're basically also saying is that you're going to continue to self-isolate if that's what you're doing. Hopefully that's what you're doing. You're continuing to self-isolate for that amount of time. And so that's the decision tree, you're faced with. Okay, I have, enough data for 100,000 people. That's good enough for me because I want to get back to a normal life. I want to get on an airplane. I want to go see family. I haven't seen my parents in X amount of months, whatever. I want to do all of those things again. So I will take the risk after 100,000, 200,000, 500,000, whatever that number is for you.
The problem again there is that people are notoriously bad at estimating risk, right? And the effect of risk, right? Until after the fact. Right. So I think most people would say, 1 in 1,000 sounds pretty good. It's less than 1%. It's a tenth of 1%.
Yeah, that's very small.
And so that's what it seems like. But when it's presented numerically that way, right? But that's not how our intuition, like I said, the motorcycle example, we perceive motorcycle to be a risky activity culturally. We have that understanding because that 1 in 1,000 number actually is something we should be worried about. Right, and it's not until if it's a 1 in 1,000 chance of, let's say, kidney failure or dialysis-dependent kidney failure. Well, that 1 in 1,000 people who ends up on dialysis will regret it incredibly deeply. Right, and say, I should have waited and this and that. But that's how our minds work. And in fact, one of the actually, I thought about this too. There's a great study in the sort of criminal justice arena that increasing penalties does not actually decrease the frequency of crime. What decreases frequency of crime is the likelihood of being caught, right? And so it's interesting is that like people, for whatever reason, on some level, if I say, you could, die 1 in 1,000 or you could get a rash in 1 in 1,000, somehow that we process that very similarly, right? That's wrong. We shouldn't process those similarly, but we do. And we need to account for the fact that people are not going to be making a rational analysis of what risk is acceptable, right? Because we have these weird tendencies in our brains to weight things. Similarly, like we don't, if I say we have 2,000 birds that are covered in oil from an oil spill, how much money are you willing to give, right? people are willing to give like $2 or something, right? But if I increase that from 2,000 to 200,000 and then to 2 million, and I sample different people, it goes up to like $4 instead of $2, right? We don't deal with multiplicative issues very well. We see that with climate change. We see that with all these things. Our minds, our emotions are not built for these numbers, right?
Or rather, our human intuitions.
Our intuitions, right?
Our heuristics
And that's the problem of making it a subjective call, is you're making it subjective on the basis, well, I want to go do Brazilian Jiu-Jitsu, and I haven't done that because of
but
this.
my argument is you have to make that call at some point
Oh,
of the
yeah,
game,
yeah, yeah.
right? And so,
but the question is, should we leave it to the public, or should we make that as a policy decision?
I think no. You have to leave it to the individual to decide if they're going to get the vaccine. I mean, you can't mandate vaccinations. You can't force.
We mandate vaccinations all the time.
You can't force adult people to get a vaccine. Especially a vaccine on a platform that's not proven. That's just not going to fly in any country in the world. I mean, people are going to say, well,
I'm sure China's already doing that.
yeah. Well, maybe that's one exception. No, but you can't mandate it, right? Because you can say that, and we talked about this, and in fact, this is probably a good time to segue into where the risk tolerance changes depending on your susceptibility to COVID, or susceptibility to dying of COVID, right? So if you are, like you said, an elderly person in a nursing home, you have diabetes and heart disease, you're 90 years old, you're not waiting for 1 million, people to get vaccinated and get the data from them. You're just getting that because the odds are overwhelmingly that the risk-benefit ratio works out in your favor. Yes, you could end up on dialysis because of it, but the odds are overwhelming that you are going to there's far more likely to benefit than not.
If you get COVID naturally, you could end up on dialysis because your kidneys at 90 aren't doing great anyway,
yeah.
right?
So in those kind of circumstances, your threshold to take the virus will require less information, right?
And that's actually, so again, let me dart sideways and then we'll come circling back. Like in my career, actually, and I've not been practicing that long, we had the option of oral polio vaccine, right? And it was taken off the market in the US, right? It's still available elsewhere in the world. And that's an interesting discussion because the oral polio vaccine is a live attenuated virus and it does have a few cases, 1 in 2.4 million, I think.
Yeah.
But there are a few cases where it reverts to wild type spontaneously and causes polio and paralyzes children, right? So 1 in 2.4 million is a very rare side effect, right? The problem is that we haven't had a single case of polio in the Western Hemisphere since like 1979, right? So if you're a kid in the US, a 1 in 2.4 million chance of getting polio from a vaccine is actually far higher than your chance of getting polio without a vaccine.
Infinitely higher.
Infinitely higher, right?
So if you don't do anything, you're not going to get polio. You take this, you might get polio.
Exactly right. Exactly right. And so that is a problem, is that, if you were just giving the oral vaccine or if there were no injectable vaccine as an option, well, you are actively harming or worsening this child's risk profile, right? And that's a tremendous problem because as a physician, that's not my job. My job is to improve the individual's risk. But as a society, if we stop vaccinating entirely, then we could end up with a generation where it just comes roaring back, right? And that's why elsewhere in the world, the oral vaccine is still available because it is easier to distribute, it's easier to take, and doesn't require trained personnel, right? You don't need anybody who can give an injection. It's just an oral dose. And so the risk 1 in 2.4 million is still considered low enough elsewhere that it's worth doing. Yeah.
Because in that case, the risk-benefit profile favors in that population giving the
correct.
vaccine.
And in that case, we're talking about a geographic population. And in the case of coronavirus, we're talking about a population segmented by age. We're segmented by gender, segmented. It's an interesting thing. Actually, we can get super. How about we get super edgy here? Men are actually at significantly higher risk than women.
Oh, so don't give it to women?
Yeah, so don't give it to women, right? Only men should get the vaccine, or men should get it first, right? Yeah. So you can take the thought process.
Just like the good old days.
Yeah. I mean, you can take this process you can take the thought process pretty far in troubling ways.
Yeah.
Right. Or ways that we would find troubling. Right. And that's kind of an interesting thing is that, what is the difference between giving, and it will be rationed at first because we're not going to have 300 million doses. So we're going to have to make some decisions about who gets it first. Right. So if we're giving it to 80-plus-year-olds with multiple medical conditions, well, why can't I get it? I want to do Brazilian Jiu-Jitsu. Like, why is the 80-year-old getting it, this and that? I mean, she's higher risk, okay, but there's going to come a time where it's like, well, who is...
And this is assuming that we give it to all these, 2-3 million 80 years old and no serious side effects emerge at a rate that makes it prohibitive to give it to the general population, right?
And actually, correct.
And again, to reemphasize the point that there's going to be a greater risk tolerance greater risk tolerance in the elderly population for side effects because the risk benefit of favors
because they're already at higher risk.
Yeah, they're the higher risk from getting coronavirus and dying. You're just bringing that risk down. Yes, maybe the risk of getting the virus still is of getting the vaccine side effects is there,
sure.
But overall that risk profile has gone down by what you've done. Now,
and then you can use that to measure what the real risk is, and then make decisions about the next layer.
Assuming that the side effects are the same in elderly versus the young.
Which again, you have a layer of uncertainty every time you make a switch.
Every time you do, yeah. So to continue the edgy conversation here, I've also posited this as well. Is it seems that children do the best of all cases. I'm telling you, yes, you have young athletes with myocarditis and chronic fatigue and all of this, but definitely there's very, very, very few cases of children dying. Are there some? Yes, there are, but
Correct.
By and large, they're much, much less. So let's say the chances of an adverse outcome in a child, whether that be chronic medical problems or death, is say X out of whatever.
It's actually
right?
so in children like less than 12, for instance, it's comparable to flu. So it's about 140, 150 deaths.
So not just deaths, but even chronic side effects. So
I don't know the numbers.
Let us just,
Sure.
peg that rate of whatever bad things happening at, an X, right?
Sure.
And then you have, the potential unknowable, especially with mRNA, platforms, unknowable long-term side effects at some other rate, Sure. If you don't know what this rate is, right, the vaccine rates, but you do kind of know what these rates are, you have to make a very deliberate, conscious decision because you don't know what risk profile you're moving them into, right? And so, and in fact, you could argue that because the risk to kids is so low and you don't know what the risks of the vaccine are just yet, it's probably a good idea right now to just not give it to kids. Now, that is a highly controversial subject and open to massive misinterpretation because you have the whole, MMR causes autism, bullshit that's been going around for years now. And now, as a physician, I'm saying, I don't think you should give this vaccine to kids, So that's very, Sure. easy to misinterpret what I'm saying here, but it's all about risk profiles here, and it's only because we don't know the risk profile Correct. In this new platform, especially because it's genetic, near genetic material, and you're giving it to kids who have another 80, 90 years to go. You have no idea what's going to happen to those kids. So, the threshold, the risk tolerance for the vaccine should be much higher for kids than it should be for, say, a 90-year-old living in a nursing home, right? And they have to be treated as completely separate sort of risk profiles. And I think that's the central, that should be one of the central messages of our conversation is that we have to think about this in terms of relative risk. There's a risk of getting the coronavirus and the side effects of that, the risk of the vaccine. Some of those risks are unknown because we have a new platform. And then at some point in time, you have to make a decision about which is the lesser risk. And the more vaccine data comes out, the more we will know what that risk profile looks like. And right now we don't know.
And we don't know. And again, that even the point of knowledge even is not binary. It's not like at some point we'll know, right? What will happen, and a better way to put it is, right now we know that there probably are not major side effects in the first 3 months for 30,000. Rarer than 10, probably more like 10,000 to be able to tell the difference from chance, right? So it's probably, if there is any side effect it's probably more rare than 1 in 10,000, right? Or it happens after 3 months. So as we give more doses, as we give more people, and as we experience a longer time frame, the bounds of our comfort and knowledge will expand. It'll never be, or not never, but it's going to be a long time before we really can say, yeah, we understand this pretty well, right? But it's not an on-off, oh, now we know it's safe. No, we don't. That moment is not going to come for a long, long time.
Yeah, we will slowly approach some clarity on the issue.
Right. It will be more, we'll say, okay, now we're comfortable that the risks are less than 1 in 10,000. Now less than 1 in 30,000. Now less than 1 in 50, 1 in 100.
And
right?
These are the risks.
For these, and these are the risks, right?
This is the list of things we found happens when you give this, conversely, to be more optimistic, to sort of be optimistic about this, it could be that, these mRNA platforms are some sort of revolutionary. Somehow they work flawlessly. I'm hoping that's the case.
Yeah, I mean, and so that's certainly the upside. And we're talking about positive black swans, right? We're talking about negative black swans. But the opportunity here is if this platform plays out, right? We went from disease to sequence in 9 days, right? From sequence to vaccine, mRNA. Vaccine
in a few months. Because the first
the first dose was like March.
In March, exactly right. Yeah.
And so from encountering a novel disease to having a vaccine to test, right, was incredibly rapid. I mean, the rotavirus vaccine, just to give for people listening, we're talking about the rotavirus vaccine, that took 15 years. Right, and even and now that's a cautionary tale on the other end. Is despite 15 years of examination and 50 years of prior research on rotavirus, right? We still didn't foresee the intussusception, right? So, but barring the unknown, if we start to speed up that process, we can make our mistakes faster and we can get treatments faster, right? And the possibility of having a better vaccine against multi-drug resistant TB, right? Or a better vaccine against MRSA. Or, it may be a way out of our post-antibiotic era, because we find something that we can trigger our immune system to fight something, and we may be that far ahead.
Yeah, exactly right. We identify whatever, protein it is on a bacteria or a virus. We can easily find out what the mRNA sequence for that needs to be. That's not a very large leap at all. And in fact, if we find out that this vaccine works great, there's no side effects, then we never have to worry about a coronavirus-specific pandemic again.
Correct.
Because unless there's some other spike protein or unless the spike protein changes, every time there's one that comes up, you sequence it, find out, oh, it still has the same spike protein. I know you. I'm gonna come up with an mRNA sequence.
We're already seeing that. Some what they call native immunity, right? From previous coronavirus. There are some people that seem to be immune because they happen to make antibodies that are cross-reactive to the new one. Right? And so that also can happen, is that if we're giving the spike protein, well, what if they all use spike protein similarly? We could be, basically curing multiple viruses in one go. These very exciting possibilities.
Yeah, I mean the idea that and not only that, but it's easy to sequence as well, right? So you're like,
this is incredible.
This is the antigen. This is how it's coded, and we're just going to make that code ourselves and give it to the body to create antibodies for. I mean that's you can sort of almost automate it at some point, right? You're
it removes. There's the plus or minus, right? Because for me right now, as things stand, I would much rather have the protein, the Sanofi vaccine or Novavax or whatever. I would much rather have that than having mRNA. That's because the profile is more familiar to us, right? But the problem there is there's an extra manufacturing step because I have to give it to yeast outside my body. They have to make it. We have to harvest it, purify it, and then give it as a protein. Well, with the mRNA, we basically skip all that manufacturing. We just give the mRNA, right? And so there's a potential for also, and there's some cool ideas on microfactories. I don't know if you've seen those.
Well, just to stop you there, though, but the mRNA vaccines have their own challenges. So you talk about manufacturing.
Absolutely.
There's an extra step. The biggest by far problem is mRNA is a very, it's a very delicate molecule. It's a long chain, very incredibly delicate molecule, easy to degrade, and that's why these vaccines have to be transported in extremely cold conditions, because if they're room temperature, they denature right away.
Correct.
So if you think about billions of doses that need to be created, you have to have a chain of custody, a chain of cold, I guess, whatever it's called, to make sure that those, you have one batch that goes to room temperature, that batch is gone.
And that speaks to, again, just in what you're saying, you have to think about that, right? It also speaks to this idea, like the plausibility of there being some reverse transcription to keep this going. If it's that easy to degrade at room temperature, let alone body temperature, right? Then, you inject it and it's degraded by that logic, right? Because that's 98.6 degrees versus -70 where it's kept stable, right? So there's got to be something going on that stabilizes this long enough for it to be more than one spike protein, right?
Yeah, and I'm not sure, maybe the liposomal layer, I'm not sure. I'm not sure what the mechanism is that allows it to stay long enough to be ingested by the
anyway, we've already covered the idea. The potential there is for the unknown side effect. That's the important thing. Who knows what it is?
Yeah.
Right.
Upside is that this could be like the the coronavirus ushered a revolution in vaccine research. If this is how we are going to start approaching.
Well, and it also, I think, highlighted the idea of how much. So, we all, it's very easy to enjoy hating Trump, right? But his, the administration's creation of Operation Warp Speed, where basically they basically told the pharmaceutical companies, Moderna and Pfizer and all these guys, that, hey, look, we're going to take the financial hit for whatever you're doing.
Yeah.
Right? So we're actually going to pay you, and we're going to pay you to make millions of doses. So don't make one or two to test, right? Which is what they usually do. They make 20 to 40, they test 20 to 40. They see how that goes. Then they make 100 or 200. They test those, they see how that goes. And then they move into phase 3 trials where they actually, right? So the government said, skip all that, make 100 million doses from the beginning. And then start phase 3 trials right away, right? And so it just gives you the idea that the amount of our ability as a society, perhaps, when we really put our mind to it, to potentiate medical device development and speed is there. If we get rid of red tape, if we get rid of some of these things. Now, there are sometimes where red tape serves a purpose, right? So like I'm a little bit concerned about the idea that healthcare workers are at tier 1 for the Moderna vaccine.
Well, there's not going to be mandated, though.
Not mandated, I understand, but well, you say that. Like the flu vaccine is not mandated, right?
Yeah, it's not.
It's not, but there are plenty of hospitals. There are plenty of hospitals that won't hire me as a local.
In this case, though, it's actually quite different, right? So the Moderna, Pfizer vaccines, they are new platforms. And you can make a great argument that they have not been tested. So I don't feel. I don't know that I would.
You can make a scientific argument, but that's how hospital administration works. Honestly.
I really do think. It's unless there's more data on there, it's going to be very difficult to mandate people. And this
You're
really
far
comes.
more optimistic than I am.
No, I think I am.
Society.
At least the institution I work for, I'm quite.
I think you have a good institution, dude. I really do. But that speaks because you told.
Will there be some administrators out there that will force it down the throats of nurses and doctors? I'm sure there will be, but I don't think that will be par for the course. And I think that as more data comes out, a year from now, say, right?
Yeah.
Then maybe there'll be some mandating going on.
And actually, there was that podcast we listened to actually as well pointed out that actually most of these because with the rotavirus vaccine, intussusception popped up on the radar within 2 months.
Right. Yeah.
Right. So it wasn't. It was actually less than a year. It was taken off the market. The first vaccine. And of course, that was in the context of far less surveillance than these vaccines. These are going to be under the microscope,
exactly.
right?
And that's actually what makes me optimistic about this is we're going to be, this is a grand medical experiment where we will have like millions of patients' data out by February.
Yeah.
By February, we will have millions of doses out there, and there's going to be people watching them like a hawk.
Right.
In some countries, it'll probably have to register on an app, and then it'll be followed up. Are you having symptoms? Blah blah. It's very easy to automate that
so I don't
stuff.
think we're necessarily even talking about this time next year. I think we're talking about February, March.
Yeah, February, March, we should have.
You've got millions of doses,
yeah.
And you will say, okay, at least the short-term data, and even at that point, short-term will be 6 months, 8 months, right?
Yeah.
And it's relatively rare for vaccines. In fact, I can't think of any off the top of my head. Vaccines that have late side effects beyond like 6 or 8 months.
Yeah.
Can you think of any off the top of your head?
No. So yeah, that's exactly right. So by March myself is when I probably will
I can't
be making that decision for myself. It's like by then there will be millions of patients.
Millions of patients in 6 to 8 months, right?
Yeah.
Which for vaccines, as far as we know,
Yeah.
is actually a pretty reasonable time frame.
And then there's a little bit of taking a chance on the mRNA platform. Like, all right, this seems to be great,
So here's the really tricky part, right? Is the mRNA is fundamentally coding for the spike protein, right? The I just said their name a second ago, not Novavax, but the Sanofi, right? They're entering phase 3 trials now, December, right? So by the time the Moderna vaccine has 100 million, or not 100, but has 1 million or 2 million doses out to prove efficacy and safety for that, the Sanofi vaccine, which is the exact same spike protein, right, will also have safety and efficacy data on a lesser set. So you'll actually have an interesting moment where you can choose your platform, right? You can either choose a more established platform with less safety data specific to that adjuvant combination, or you can choose a brand new platform that has more data, 1 million or 2 million doses. And so there'll be an interesting, like, weird moment where you have to sort of like figure out which one.
I also read because of the issues with transportation and the sort of chain of cold that you need, poorer countries are not going to be using the mRNA platform at all. They're just going to be using the the replication deficit adenovirus platforms, where they don't require.
There are some. There are also inactivated virus options that are coming out. Those are a little bit. There are some interesting concerns that the inactivated virus, because it's whole virus, may have more potential to trigger, or live virus as well, may have more potential to trigger vaccine-enhanced disease. So, in fact, instead of protecting you, the vaccine may actually make it worse if you get real coronavirus, which is less likely. Now, after the fact, we can say it's less likely with spike protein.
Yeah.
Because that at least has not shown up. And that's important, right? Because there are, I forget which one it was. Certainly, I think we've seen it with some of the HIV attempts. But there are vaccines we've tried where, in fact, what happened was the disease got worse after you got the vaccine. So we gave you the vaccine. It wasn't a vaccine, I guess, in that case, but we gave you the presumed vaccine, the inactivated virus or the live attenuated virus, whatever. And then when you encountered the real virus, you actually got sicker than if you hadn't had any virus, any vaccine at all. RSV, I think had something like that. So we haven't seen that with these mRNA vaccines, and that's actually promising. That's actually an important, at least 1 in 30,000. We haven't seen anybody that had convincingly more severe disease after encountering the vaccine, right? And that's important because that is more possible, I think, with the inactivated vaccines, and it may ultimately come out that the mRNA vaccines are more safe.
Yeah, exactly right. Yeah.
Then we just don't know.
Yeah, we don't know.
But
yeah, and again, an optimistic outcome of this is that not only are extremely safe, but they're way more efficacious, right? Because they code for just that protein, and so you can have a very specific antibody response to a very specific sort of protein, right? And
there's all kinds of. Even think about that. There are. So for instance,
there's also tumor
rheumatic-
markers you could do this for, right? So if a tumor is expressing a certain protein, if a tumor is expressing a certain protein, then all you have to do is tell the immune system, all right, this is an antigen that doesn't belong, and generate some sort of immune response against it, and then the immune system starts attacking the cancer. So this also opens the door to potential cancer therapy as well.
Sure.
So again, the upside is that we may be discussing the beginning of a revolution in vaccine therapy, because if something is 95% efficacious, I mean, just think about that for a second too.
When was the last time you saw a 95% effective flu vaccine?
Yeah, exactly, right. So could they also do this for the flu at some point in time, right? I mean, because here's the thing, like one of the reasons the flu doesn't work is each year we're guessing what strains are going to be. Well, what if we didn't have to? Right?
Because we can do it fast enough.
Exactly right. Because the flu season starts, and then we
check what it is.
We check what it is.
If it changes in the middle, we do another one.
Exactly right. Yeah, because we can ramp it up because you could automate this process. In the future, 10 years from now, you can imagine you input the flu virus and out comes an mRNA vaccine.
As long as we're speculating, actually, I think you start to talk about some fun. Sci-fi type stuff, right? But with the advent of CRISPR and stuff like that, actually, the potential that has shown, not CRISPR itself, but the concept there, is, you could have a vaccine creator in your house.
Oh, yeah.
Right? Is actually mRNA replication is sufficiently automatable, perhaps, that, the scientists actually isolate, oh, hey, the flu has changed this year. Here's the sequence. Please print this sequence out and inject yourself.
I don't know that you need it in a home. You just go to Walgreens or something down the street and do it.
I don't trust Walgreens. I don't know what you're talking about. I want it in my house.
Or doctors' offices could have their own vaccine.
I don't trust my doctor either.
Or your office.
Want it in
your
my
office
own
could
house.
have. Your office could have the machine itself. No, but that's a good point. Is we could be discussing a platform that is the beginning of a revolution, right? So. The human species, when it's really pressed against the wall, has been able to really pull some amazing things out of its ass, right?
Yeah, totally. Yeah.
Even when it really needed to, the human race could get to the moon, right? Because then it was a nationalistic fight. As soon as it got there, the moon program just completely died, right? We haven't gone there for 50 years, 60 years now. We haven't gone to the moon. But when it was a ball measuring contest, then sure, we pull in on all the stops, willing to risk anybody's life to get there, right? And now we just don't care.
Yeah.
So it could be, this is our anti-fragile moment in a sense, right? Because you even see people are rethinking how economies should be structured. We've just realized that supply chains are way too efficient, and so therefore fragile. And so maybe we should start producing locally. So as bad as the coronavirus was, there's
I'm less
also,
hopeful that we learned that lesson. But yes, it certainly showed. I think we've been shown that. I just don't. Yeah. I think people want their $1 Wonder Bread too much. I don't think they're willing to put dollars to the wall to make our supply chains more robust or anti-fragile. So I don't think we've learned that lesson
just yet.
I think certainly we have been shown the flaw in the plan, but I somehow suspect that Walmart and Amazon will continue to offer efficient, low-cost.
At the very least, it's uncovered how grossly unfair our current economic models are, right? In this pandemic, you just hear about the next billionaire that's crossed $100 billion in capitalization. I think Elon Musk recently went up to over $100 billion, and so did a bunch of other people. And then at the same time, you have massive unemployment at the other end of the spectrum. More and more people are just absolutely fed up with the degree of income inequality. Now, I don't know how you fix that exactly, but it's become a concern that can't be ignored for much longer. COVID accelerated that sort of divergence that was happening anyway, but it accelerated that to a large extent.
I guess I'm. We've talked about this a little bit, but it's difficult to make the case that Elon Musk has not contributed something.
No, right? This is not to knock.
No, but the challenge is that. The idea of being able to have a 9-to-5 manufacturing job right? That, or even a secretarial job. Imagine AI coming. Even pretty limited AIs are out now that are able, or transcription. Do I really need a transcriptionist? I mean, we in our lifetime, I used to dictate into a phone,
Right.
and then a transcriptionist wrote down what I dictated and put it in the chart, right? Now they've all just given me Dragon things, and that entire job is gone.
Yeah.
Right. So this idea that the inequality, quote unquote, exists, but is it inequality or is it just a disproportionate contribution, right? And that's not to say that that's a good idea, by the way, right? Because you can't have people starving and then other people eating venison and have that system be stable for very long. Mm-hmm. But it's also not clear what to do about it because the nature of society has changed, that there may not be a place for anybody with, we've talked about this, what if there's no place in society for anybody with an IQ less than 120? We get to a point where all the jobs that are available are, and by the way, that's usually the minimum specified to become a physician. That's the generally accepted minimum threshold IQ to generate a physician, right, is 120. So imagine that all the jobs in the world require that. You've cut off most of humanity from having any kind of honorable work that is meaningful, right? That's a tremendous problem. And the inequality under any kind of capitalist system there is obviously going to, but then what are you going to do, right? I mean, universal basic income was some interesting ideas, and I'm sympathetic to that concept.
I think UBI at least is an experiment whose time has come. We need to start making some large-scale experiments, and then the UBI is interesting in two ways, where you can't just do UBI for a month or two, right? Because you just don't know. Like if you're only going to get paid for 2 months, your behavior is not going to change.
Right.
If you know that you're going to have a roof over your head, you're going to have, you'll be warm in the wintertime, you have access to healthcare, and you have food on the table. And because of inflation, those things are becoming cheaper and cheaper. Mm-hmm. There was a time where you had to pay a premium for electricity, right? And now electricity is considered almost like a basic human right? And that will, housing should eventually, technology makes things, less and less expensive, so that you can think that there will be some sort of 3D housing that will be fully functional with a microwave and everything. In the same way, food can be grown by robots as well. So food is almost free as well, just as water is practically free as well. I mean, you're not, you're paying a minimal amount for clean water, which is, revolutionary.
Dramatic.
It's dramatic
Absolutely.
compared to 200 years ago, say. In the same way, if you have a roof over your head and food to eat and all of those basic necessities taken care of, then you shouldn't have riots in the streets. You shouldn't have homelessness. You shouldn't have insecurity from dying of starvation or dying because you're
I guess and I certainly think it's worth an experiment, a long-term experiment. I don't disagree with you. I actually, though, my instinct is that the inequality itself is the problem, in that I think it is a somewhat false notion that we compete with each other primarily for survival, right? Because by that token, everyone in the U.S. is massively rich compared to everywhere else, almost everyone, right? But we don't feel that way. We don't act that way, right? Even the relatively poor in the U.S. are, compared to places in Africa, are phenomenally better off, right? But they don't wander around being like, middle class, relative to the rest of the world. That's not how they feel about it, right? They look at Elon Musk and they say, well, why does he have so much, right? And so I think that in fact, even if you had a universal basic income that was enough to take care of your needs, you would run into the problem that that's not why we compete. That's not why we need money or any of these things. It's actually relative social status. And that's actually defined somewhat locally and progressively less so as you move out nationally, right? And that's a huge problem because there is no bare minimum then. You could have, give everybody a nice, 2-bedroom house. And if everybody has it, it won't be enough.
See, I don't know that I agree with that entirely. So comparing like a poor person in America is different from, say, a poor person in India, right? Because at least in those societies in India or Africa or whatever, you still have some remnants of a family, sort of combined family structure, or a village sort of situation where you still have someone close by who may be related to you who can take care of you. But, you and I have both seen a homeless person out in the street, who doesn't have any family. There's really no one that can take them in.
I would argue in the urban areas of India, that's also true. I mean, people have moved from the villages to urban areas. The same fracturing has happened. I mean, certainly in places like Saudi Arabia or UAE, where they've basically imported a slave labor force that are deliberately cut off from their families, right? These people are truly dispossessed in some sense, right? So I don't know. I mean, you can make arguments, but I guess my point is like and like I said, I think we should run the experiment. I do think we should run the experiment. But my instinct is that it doesn't solve the fundamental problem of comparison. And I think that that's actually what's motivating most of it, is this idea of being able to compare one's standing and to have kind of a relative sense of pride of place, a pride of social, not class necessarily, but standing really is probably.
See, if a person is food insecure, they're home insecure, they have healthcare insecurity as well. I mean, they're fundamentally insecure, right? I think that is where the problem is. I don't think that
you'll see many of those same people own an iPhone, right? Not all, but it's not uncommon either, right? But so you have to question, why would you make that choice? If you're a rational person, right? Why would you choose to do that? And the answer is relative social standing.
Well, you can get an iPhone for like a second-hand iPhone for you can't.
I'm saying, but even back, back when an iPhone was a relatively pricey
I don't know
item.
that you know that for sure. Like is there
We've seen that in the hospital. We've absolutely seen that in the hospital.
I mean, yeah. So is there a minority of people who don't make good financial decisions? Sure, right. But there's a lot of people who are in that position because they've lost their job. They have a chronic illness. They just can't get over some calamity. They got hit by a car. I mean,
I guess my objection is to call that not a good financial decision, right? It's only not a good financial decision if you're conceiving it ahead of time in terms of insecurity, right? It's a great financial decision if you're prioritizing relative social standing. That is the correct, in fact, decision. And that's what I'm trying to say, is I think that a lot of these things are motivated. I mean, these are tropes. These are, like you go in a relatively poor area or ghetto area and, you see some decked out car with weird rims or whatever, right? Why spend money on that instead of get some health insurance, right? Why? Because they're prioritizing relative social standing. And that's the true motivator, is that in my area with this item, with this thing, I can show a certain level of standing in my community, however that's defined. And because I think that that's what's motivating, it is a very logical set of decisions. You look at it like, why would you do that? Well, of course, this is why you would do it, right? So it's not a bad money decision, right? It's only a bad money decision if you have the false understanding of what motivates people to spend money.
We should have a discussion on UBI at length.
Yeah, we've gotten off base from vaccines.
When were we talking about vaccines?
Yeah. No, so I think the key point for me, and we just circling back, so maybe we can summarize and then move on if there's anywhere to move on to, is how, and this is something Taleb wrestles with, how do you deal with an unknown risk profile? If I say, well, the risk of death, let's just say death, right? For 65 plus, if you get wild coronavirus, is 2.5%. And the risk of the vaccine is, I don't know. Right?
Yeah.
How do you compare those things?
Yeah.
Right? And I think that part of that is perhaps being a little more cautious than you would otherwise, watching a little longer, right? And then trying it out in populations where there is less to lose, right? So the higher risk population has less to lose from a riskier vaccine, just like we talked about. And so we should move down, not risk profiles, and I think this is the mistake we're making with putting healthcare workers in the top tier. Not the risk of getting coronavirus, the risk of suffering the worst consequences of coronavirus.
Right.
Right. And so those populations will have the least to lose from trying a vaccine because they have the most to lose from wild-type coronavirus. And so if you're in one of those high-risk groups, I think that you could reasonably say that, hey, after February, maybe I'll give this a shot, right? Even before February, maybe, like if you're in the 80-plus crowd. But even if you're 65-plus, I mean, I'm thinking of my parents. You know, what would I tell my parents to do? Certainly, I wouldn't tell them to take it now, right? 1 in 30,000 is still more risky.
But that position can change in early January, right?
Correct.
I mean, yeah. So just to date this this conversation here, we're talking just a little bit before Thanksgiving.
Correct.
Because this really matters. The timing of this
Yeah,
conversation
totally.
matters.
Yeah, it's a moving target, right? And rapidly so. The more and the faster it's deployed. The other interesting thing that came out, I think, that I had not thought of, but as I was reading of it, is that oddly enough, the surge may help us, right? In that, one of the big problems these vaccines face and have faced over the last 6 months is really trying to tell the difference as to whether it prevented anything.
Yeah, that's right. Yeah.
So you need enough exposure, you need enough of a risk of getting coronavirus for you to tell the difference between the vaccine and the placebo crowd.
Yeah, no, that's a great point, right? So if, for example, you go to a city where it's rampant, you give it to everyone in the nursing homes.
Correct.
You will know in 2 weeks' time if this is working.
Yep.
You know, in fact, actually, the efficaciousness is somewhat promising already from the early data. But like you're saying, it'll be
only 95
crystal.
cases.
It'll be crystal clear in like just a month or two if they decide to deploy it in very strategic ways. To any place where there's a huge outbreak, give it to all the vulnerable people there, and within a month you will know what's going on. You can just look at the hospital data. In a month's time, if you just to pick a city, like in fact that might be a great way to initially get some hard data. Pick a city that's really badly affected, give it to all the vulnerable people over there. Come back a month later and find out what the hospitalization rate is.
Correct.
And that small little experiment will tell you a whole lot.
Yeah, no, absolutely. No, and so I think that the bigger cases we have, because of the timing of the vaccine advent, may actually help speed up our ability to tell the difference, right? Yeah. And I suspect these vaccines are effective. I suspect they do have probably pretty minimal risk profiles. I suspect that the way this will play out is we find out they're safe and efficacious. Right.
I hope so.
I hope so, and certainly that's what I would think is the most probable outcome. But I certainly have reservations and would not tell my family to take it right this minute. Right now, if we do what you're saying, we kind of pick some very high risk populations, give it to them, compare. We could have good data by January, February, and say, what? Actually, it's this good. It has this many side effects. We've tested it in this many people.
I think it's already being deployed to like lots and lots of people. I mean, I think
it's still on a volunteer basis, though.
No, I don't know that there's ever going to not be a voluntary basis.
Meaning on a phase 3 trial basis. Yeah. Right. It's not post-market. I'm talking about post-market surveillance.
Gotcha. Okay.
So phase 4.
So I may be wrong about this, but I think it's already being rolled out to some certain segments of the population. At least the system that I work for as a physician, I do know that they already have contracted with some pharmaceutical companies to procure a certain batch of vaccines for its healthcare workers. So there's organizations all over the country that are getting the vaccines for themselves. Sure. So it's not going to take long at all for this to deploy. The amount of urgency here is so high.
So then let's continue your question. Actually, that's a great place to move on to next. Is you asked the question. Okay, so we agree. 80 plus first. It's nursing homes first. Okay, then we get enough. What, 1 million doses? Right. We have good data in that population. We find it is just as effective as we think 95%. Let's say 95%, and then we move on to 65 plus. Right? So, we do that. So when are you taking it? When am I taking it? Right? Hey, healthy people in their 40s with no other medical problems, right? What's your feeling on?
So it would depend entirely on what is the side effect risk.
No,
we I think already have compartmentalized the mRNA platform into black box side effects that may occur years later because we're dealing with genetic material. I've sort of made a decision that I can't wait for 10 years to find out that there's going to be an effect. if there isn't any immediate, obvious effect, then I'm just going to let that black box
be what
I'm
it
going
is.
I'm going to have to tolerate that risk, unknown risk, whatever that is.
Mm-hmm.
Then the other stuff is, things like hypersensitivity reactions or whatever, that you can unexpectedly get. Transverse myelitis, was described in one of the studies as well. So then the next question is, what percentage of those incidents are occurring? What is the number? Correct. So I don't know if it's 1 in 200,000, 1 in 300,000. I would feel pretty good about my own personal risk, if those kind of numbers were available in the next, I wouldn't put a date on it. I would just put a when is that data being available sort of framing of it is. If that's available in January, then that's great. If it's available in February, then that's great.
Yeah, that's kind of interesting. I think that.
I do think that I would probably chance the vaccine, provided it doesn't cause any catastrophic side effects, rather than chance the COVID itself, because of the late effects and stuff like that. So
I would agree with that. I think, yes, I would agree with that even at a young age. Maybe not children, right? Probably not children, but certainly people in their 40s, even 30s. I would say, yeah, probably better to get the vaccine than the wild virus, right? Assuming that this continues to play out safe and efficacious right. But I guess that's what I was trying to get at is, let's say, the numbers start, you're just walking a counter, right? And the numbers start piling up. Okay, we're at 30,000 right now. Now we're at 50. Now we're at 100,000. Now 200,000, 400,000, 800,000, right? And it continues to be 95% effective, and we're not really seeing side effects, right? We see, let's say, no convincing side effects that are other than the mild achiness and fatigue that are reported, right? And by the way, actually, it's worth saying is, we shouldn't pass over that too easily, right? Is that all of these seem to induce a couple shitty days.
Sure, yeah.
Right? So people should be aware that you're going to feel run down, flu-like, achy, tired, fever. It's not the flu vaccine, which, very few people relatively have any significant degree of this. This is a significant number of people who have a couple shitty days, right? So that's important to know, that we're, just expectations, right? But let's say we don't see anything else, right? And now we're at 400,000, 500,000. It's been 3 months, 5 months, 6 months.
Oh yeah, I don't even know
you would jump on it. I'm saying where along that pathway do you think you jump on?
Just to arbitrarily come up with numbers, I think 500,000, but that's only because I think we will get to 500,000 really fast, and probably 3 months. So 500,000 people and 3 months worth of data, I think is
3 months from when? Because the first dose was March.
3 months after 500,000 people have been.
Oh, I see. 300.
And I think we'll get there really fast. I mean, they're talking about making hundreds.
That's probably going to be what? April?
Mid-January. So mid-January is when we will have 500,000.
Yeah, that's what I'm saying. And then April, so 3 months after January.
By April, we'll have 3 months of data on 500,000 people. And, again, optimistic scenarios that we will be approaching a greater level of optimism that there aren't any untoward side effects. And if there aren't, then, it's taking the vaccine and then going to the races.
It's funny because I'm more conservative than you, but I'm willing to count back farther. So it ends up almost the same. Because I feel like I would want 8 months of data, right? But I'm willing to count all the way back to probably June, July. But I don't think we have that much data. I mean, how many people? I don't know the exact enrollment speed. I mean, but we moved almost straight. I mean, the first one was March,
but that was,
I think by July
so that very
we were doing
first.
phase 3.
If you're talking about the New England Journal of Medicine article about the March ones,
that was phase 1.
That was 45 patients.
Right, that was phase 1,
nothing
right?
at all, right? I mean,
but that was in March.
Yeah,
and that's what I'm saying. So when did phase 3 start? I think
the
phase
results
3 started in June.
Did it start in June?
That's what I think.
I think it was just a few months ago. I mean, so August maybe?
Okay, August. Okay, fine, whatever. So
but even
September,
then,
fine.
But even then, I mean, the number though is still just 30,000. So it's really a small number. So yes, you have more time, but is that really meaningful when it's just 30,000 people?
Well, so that's the question.
So
right?
I would say 30,000 multiplied by 3 months is not as much as 30,000 multiplied by 8 months is not as much as 500,000 multiplied by 3 months. I think the latter is more meaningful. Because most side
No,
effects occur in 3
I
months.
I have the different
Bias.
bias. Yeah, in that, I think if you say one, the severe side effects are less than 1 in 30,000, right? I'm almost willing to do that on its own, but now I don't know long term. So that same 30,000 extended over 8 months, now I also have time data, right? And that makes me comfortable. So actually, I'm perhaps more risk.
No,
I think it ends up the same as you did. I think roughly, because if I'm counting back to August, September.
What was your number again? 30,000 or 100,000 or?
Probably 100,000.
100,000 times 8 months.
100,000 times 8 months.
So would you really know?
No, hang on. That's not an accurate representation.
Yeah.
I think it works out the same because I would want 100,000 numerically, right? But I don't need 100,000 times months. I'm okay with 30,000 for 8 months and 100,000 for 1 month or 2 months. You know what I mean? I'm okay with separate bits of data.
Sure.
Right? So I think we have 30,000.
So the 30,000 people who got it already, by March you'll have what?
And I guess that's what I'm saying is So I feel like, March, April probably I'd be, assuming nothing has shown up and we have well over 100,000 people with no short-term side effects.
What if I give you 1 million in 1 month?
Yeah, no, I don't think I'd be cool with that. I guess that's exactly my point, right? Is 1 million people but only 1 month of data, I don't think I'd be okay with. And then similarly, if you only gave it to 500 people but waited a year, I don't think that's meaningful, right? You need some combination of time and numbers. But I feel like those are separate metrics. So I feel like the time data, I'm okay with, like, even 10,000 or 30,000.
So here's the thing: you want to wait longer because you don't know about the potential black box, called genetic side effects of giving mRNA. Is that why? Well, so my argument is that how do you know 8 months is a safe duration? You're just making that number up too.
So that's actually a little bit, it is made up, totally. It's a little bit projected in that, I'm trying to think of even wild viruses, right, that are fully recovered but have lingering effects or whatever. And would you pick up on that in 8 months, right? And I think you would. I can't conceive, because again, you're injecting genetic material. The virus itself is injecting genetic material, right? I mean, coronavirus itself is mRNA, so is flu, so all these things are injecting genetic material. It's not in the liposome, but it's injecting genetic material. And I can't think of a circumstance in which you recover fully and then more than 8 months later, something pops up as a result of the virus.
Yeah, but what I'm saying is that in that sense, you don't even need 8 months, right? I mean, 3 months might be more than enough. So if you're not going to get something after 3 months, you think 8 months later is really necessary?
So I'm trying to...
That argument works for 3 months as well, is what I'm saying.
Well, the one that I have in mind actually is cryoglobulinemia with HCV.
What happens there?
Hepatitis C can cause a hypercryoglobulinemia. You can get like a vascular.
No, but how much time are we talking?
That's what I'm trying to remember. I feel like I remember 8 months,
8
but
months?
I could have been making that up.
I mean, how would you even know? How can you make a causal link? That's the other thing is you can never make a causal link between a viral infection and something that happened 8 months later. Like which brilliant house MD scientist is putting those two? It's not you. No, you can't, right? I mean, in your review of systems.
I can.
In the last 1 year, have you ever had a viral infection? I'm not ever asking that question, right? So how would you ever capture that?
What kind of doctor are you? You don't ask about every viral infection ever?
Although there is that patient who will tell me about some childhood infection they had when they were 2 years old. I'm like, God. Anyway, so I mean that's a point: is how is that data ever captured, right? Like how do we ever know? Like if someone comes up with MS, for example, MS is a great example, right? How do you know it wasn't because of some viral infection 3 years ago? Like we don't know. That data is lost, right? It's just you can't make those associations. Oh, I had a cold, but it was a year ago. I'm like, yeah, be quiet, right? But maybe it was that cold, that caused it. That data would be lost. So I don't know that we would ever be able to capture that association. Maybe it does happen, and we just, why do people get MS? Maybe because they got a cold 4 years ago.